Hello, my name is Bella Welch, co-chair of Rocket City Weatherfest 2024. I really hope you guys are having an amazing time so far. If you don't already know, you're about to watch Rocket City Weatherfest's first ever natural disasters panel. Our main goal in having this panel at Rocket City Weatherfest this year is to go beyond educating on hazards and disasters specific to the Tennessee Valley, like tornadoes, which I'm sure you've heard a lot about today, and talk about what disasters look like all over the world. We have some really amazing people that are going to share their experiences with you from both here locally and all over the world. I really hope you enjoy.
Hello, uh, hello, all the participants to the 2024 Rocket City Weather Festival. It's a great honor to present our understanding tsunami research in Japan. My name is Nobuhito Mori, working at Disaster Prevention Research Institute of Kyoto University in Japan. Today, I'm briefly introduce you about giant tsunami and lesson in Japan. So first of all, this is an outline of the giant tsunami along the subduction zone. Major giant tsunami can be occurred around the subduction zone. So here uh, uh, we have a trench or trough, and then sea plate is submerged under the knees of the continental plate. So dashed line indicate rupture zone. So once this length and width can be few hundred kilometers. And the slip of this rupture patch, it can be a few meter to the 50 meter, depend on the size of the earthquake. But this kind of setup can generate extremely large tsunami up to 10 to 20 meter, depending on the location. So a large giant tsunami, it can be occurred around Pacific Rim, like Japan Trench, Tonankai Trench, or Cascadian subduction zone along the west coast of the United States. So this shows the historical giant tsunamis last 100 years. So most significant and largest tsunami was occurred in Chile in 9660, which magnitude was 9.5. It was a historically largest earthquake, and it was a trigger to the giant tsunami along the Chilean coast. And after that, we could see several giant tsunami, like a 2004 Indian Ocean tsunami, or 2011 Tohoku tsunami. So today I briefly introduce to you what happened uh, in in Japan by 2011 Tohoku earthquake tsunami case. So in 2011 Tohoku earthquake tsunami, magnitude was 9.0. It was one of the top class largest tsunami historically, and it was occurred March 11, 2011. Then rupture area was approximately 450 kilometer by 200 kilometers, and then which generated giant tsunami, 130 kilometer off coast of the Miyagi prefecture. And the tsunami totally inundated over 6,000 square kilometer of the Japan land, and then official fatality were close to 20,000 with additional 1,500 missing. And one more remarkable thing is more than 90% of the fatality were due to the tsunami, which was a kind of very characteristic result by giant tsunami. This is because tsunami is a kind of wave, so water density is 1,000 times larger than air. Once water massive water attack to the structure or human being, it's pretty easily to give catastrophic damage compared to the wind. So this is one example how tsunami was large in 2011 case. So vertical bar indicated tsunami height on the land side. So from Tokyo to Hokkaido, North Island, Japan, over 10-meter land-up height, height of the tsunami on the land could be observed over 500 kilometers from north to south. So you can imagine, entire 500-kilometer coast were inundated by over 10-meter height tsunami. So it was pretty massive. So this is a similar figure, but looking different view. So now you are looking latitude from 34 degree to 96 degree from south to north, and then vertical axis is the latitude and horizontal axis indicate the height of the tsunami on the land side. So 10 meter means a 10-meter tsunami height, maximum tsunami height at the end of the land. So maximally, tsunami height was over close to 40 meter around the epicenter. So maximum land up was 40.0, and then land up around Fukushima nuclear power plant was over 15 meter. So you could imagine how tsunami was massive and how widely affected this event. Once this kind of large tsunami attack to the land, you could see the very catastrophic damage in the town or cities. So this is one example, Otsuchi town at Iwate Prefecture in Japan. So this is Otsuchi town before the earthquake and tsunami. This is a kind of a small fishery town facing to the Pacific coast. Right-hand side indicates Pacific Ocean, and left-hand side indicates a mountain area. So this is the same view after the earthquake and tsunami. You could see over more than half of the town were totally washed away. So in this town, 30% of the residents were died by the tsunami. So it make it pretty difficult to recover this town, both economically and culturally, because there were so many missing people in this town. So if we saw this town just after the earthquake, this is a snapshot of this Otsuchi town just 1 month after the earthquake. So entire this area was a residential area, but due to the earthquake, all the buildings are almost washed away. So there was no physically standing building except 1, 2, 3 building in this town. So when I made this slide, we also got a new type of the 4th type earthquake and tsunami in 1st of January this year. So this is not extreme massive, but because magnitude was 9.5, sorry, 7.5, but it still gave a significant damage along the coastal town like this. So what historical event means. So 2011 Tohoku tsunami was the first case where modern well-developed tsunami countermeasure faced such kind of extreme event. Because 1960 Chilean tsunami or 2004 Indian Ocean tsunami attacked to kind of developing area, but 2011 Tohoku tsunami attacked to the kind of modern tsunami countermeasure. However, we couldn't prevent tsunami forces in most of the areas, and the casualty were 20,000 people, as I mentioned previously. So among the most important issue in natural science, engineering, social science for this global community is learn and to improve tsunami disaster countermeasures based on what we could learn from this event. So after 2011, it already passed 12 years. We have been working how we could reduce casualty and damages by such kind of giant tsunami. So this is my summarized slide. So basically, there's no one solution to mitigate catastrophic disaster by giant tsunami. So multiple and comprehensive preparation is necessary to reduce the disaster from giant tsunami. So top panel indicate forecast and the bottom panel indicate a long-term assessment. So forecast and warning system is important to save human life. So uh, for forecast, we need a monitoring network that can be consist with floating offshore buoy and underwater pressure sensor and so on. And then such kind of monitoring network can immediately tell us size and timing of the tsunami to the residence people. And then media or cellular phone can be useful to give us such kind of information to the residents. So forecast and early warning can save the life. And on the other hand, forecast and warning cannot save our property. So prediction and the long-term assessment is pretty important. So once we know the expected size of the tsunami, we can prepare the seawall or other hardware measure to reduce tsunami forces acting on the houses or buildings. And then if expected tsunami is too high, relocation is also possible in advance. So based on our historical uh, giant tsunamis, we realize multiple comprehensive preparation is a key issue to reduce damage by giant tsunamis. And the similar preparation can be applied to the tropical cyclone, hurricane activity, or to reduce hurricane disasters, forecast warning, and the combination of the long-term assessment is also necessary. So there's a clear synergy between tsunami tsunami disaster risk reduction and hurricane disaster risk reduction. So we are working two different phenomena together. Again, thank you very much to give us this kind of great opportunity, and I hope this festival will be succeeded very well. Thank you very much.
Hello, my name is Ronan Lucy. I am a research associate at the University of Alabama in Huntsville's Earth Systems Science Center, and a proud graduate of the University of Alabama in Huntsville. And thank you so much for the invitation for me to participate virtually in the disasters panel at this year's Rocket City WeatherFest. Briefly, I'm going to talk about some of the experience that I have, particularly related to my work with NASA's Earth Science Disasters Program, and some of the disasters that I've looked at and studied and led responses for NASA, and how those disasters have impacted the communities that they've affected. So a little bit about myself to start off this panel discussion. I'm originally from Connecticut. My bachelor's degree is in geography from the University of Massachusetts Amherst. And I didn't know when I graduated exactly what I wanted to work in, other than the fact that I was very interested in geography and people and places and cultures, and into geographic information systems, GIS. I was fortunate to have the opportunity to work after college at Oak Ridge National Laboratory's Geographic Information Science Technology Group, which is a really valuable one-year work experience for me, working specifically in GIS and applications. However, when I was working there, I also knew that I also gained the appreciation for having a master's degree and advanced degree. That's something I knew I wanted to do. So I ended up applying for a graduate research assistantship, a GRA, at the University of Alabama in Huntsville with NASA's Surveyor program. I had the opportunity to get my master's degree in Earth System Science at UAH. I graduated in 2019, and while studying for my master's degree, I worked with NASA's Surveyor program in the Hindu Kush Himalaya region, project on developing capacity in in regions around the world, where we work on collaborative solutions for a variety of problems and issues due to a variety of factors, things including agriculture, food and water security, climate change, uh, disasters, of course. So that was a really valuable opportunity for me and a great experience, and I'm really glad I had that chance. And when I graduated from UAH in 2019 and finished my time with Surveyor, I was really excited about the potential of staying here in Huntsville and working with UAH, working on other NASA projects. And I had the opportunity to accept a position working at UAH's Earth System Science Center full time with the NASA Disasters Program as a support member. And I've done that for almost 5 years now. I now serve as a center disaster coordinator for the NASA Disasters Program, uh, which is really exciting, working with other centers to bring NASA's capabilities to the table across the disaster cycle, from risk and resilience planning prior to an event to responding to an event and then recovering from an event. And so I've really enjoyed the opportunity to bring all of NASA's data and science capabilities to the table to help our end users and stakeholders make more informed decisions when it comes to disasters. So some specific disasters that I've researched within my last 5 years here at UAH with the NASA Disasters Program. I had the opportunity to serve as an event lead, leading leading NASA's Disasters Program's efforts for Hurricanes Eta and Iota. These were two back-to-back very strong Category 4 hurricanes that impacted Central America, very similar tracks and locations where those back-to-back hurricanes impacted. Um, and this was a memorable experience for me because of the gravity of damage that occurred due to those storms, the number of different stakeholders that we were working with, the amount of data, geospatial data, satellite data, remote sensing data that we worked with for the event to look at different phenomenon related to hurricanes, such as flooding, wind damage, building damage, storm surge, variety of different hazards, and the gravity of recovery, how the population in many of the areas impacted was vulnerable, and in vulnerable areas, the amount of recovery needed is generally greater, and the ability for me and the NASA team and the UAH folks that supported us to be able to do the work that we did required a strong team effort, a very strong collaborative effort, and having an impact on society was something that, and on the stakeholders that we worked with, was something that was really gratifying for me. Where I felt like my work was really making a difference in terms of recovery and response to hurricanes of that magnitude. And that was a few years ago, early on in my career, first real opportunity for me to lead an event response. And that's something that I really enjoyed stepping up to the plate for. So that was a specific series of disasters that really impacted my career, really wanted me to continue working in this area. Another hurricane that happened more recently domestically, Hurricane Ian, which impacted Florida, was another major event in the Southeast US, one that caused a lot of damage to Florida. Again, a lot of work done in the flood mapping and damage mapping in Florida. Uh, we had the opportunity to work with nonprofits during that, and domestic agencies like FEMA. And again, the ability to work with these agencies that are on the ground doing the work, being able to inform their decisions, make them more actionable and impactful by providing some of this contextual information and filling in gaps where they might not be getting data from other sources, was something that I found really impactful in the work that we do here in Huntsville. And so Hurricane Ian would be a domestic example of another disaster that really impacted my career. And of course, I have family as well in that area, so there's certainly a personal level to that response. Um, in terms of effective and ineffective emergency protocols that I've seen, having worked with a variety of response agencies, both at state, local, and federal levels, and regional levels, internationally and domestically, I've seen a lot of different protocols that have been followed, and I've certainly seen trends in what have been effective measures for working with disasters, and ineffective ones. Communication and trust are always going to be major factors when it comes to emergency responders and who they listen to and who they receive data from. In the heat of the moment, during the middle of an event, for example, an emergency responder is not going to be exploring using new data. They're going to want to go to what they can trust and what they can identify, and what they can believe in terms of impactful, actionable data, um, and they want to have the confidence to be able to say, yes, this is what we're seeing. And so building those connections, building that communication, building that trust prior to an event happening, kind of, I would call it blue sky conversations and engagements, are really important. Um, that's something that I saw throughout several event responses that we've done over the last 5 years, where our work was magnified in its impact, and would have probably otherwise been ineffective had we not had those conversations and explaining what different data products from satellites are describing, what they're showing, what you can determine from a product, what you can't determine from a product. Those are all important considerations. And are effective protocols for emergency management. And I think another really important thing to note is to really understand the needs of different communities, understanding that those needs are going to be different depending on different community factors, and work towards meeting their needs. There's not a one size fits all approach to disaster mitigation. And there's a lot of really cool science being done, a lot of really cool ways of doing science, things like machine learning, artificial intelligence, really cool new data sets that have higher spatial and temporal resolution than we've ever seen before. But oftentimes when we talk with end users and stakeholders in the disaster response community, they appreciate these factors, but the most important thing to them is, what decisions can I make from this information? And those decisions that are being made are not the same as the community next to them, or the community 10 miles away, or if it's a private sector company versus a nonprofit. Those decisions will vary. And so making sure that that is acknowledged when working in disasters is important. And you can tailor solutions for different agencies. For example, some agencies might care about flooding in vegetated areas, and other groups might not. So understanding those things prior to producing and delivering products is really important. Something I've noticed across a variety of responses. So something else to consider if you work in the emergency management field or the weather community, making sure you've built that communication and trust with your communities, and then making sure you really understand what they need, rather than trying to impose a solution upon them without really understanding their needs, which I would consider to be the ineffective emergency protocol. Uh, and then some misconceptions. I would say, in terms of working in the disaster field, um, in terms of protocols, um, to make a difference, you have to be on the ground at the site of the disaster. I would say that's a misconception, because of all of the aerial assets that we have nowadays. Earth observation data. There are opportunities to make a difference in policy, and a variety of different ways that you can make a difference, without necessarily being on the ground supporting. So I would say that's a misconception about emergency management, is that to be an effective emergency manager and to mitigate impacts from disasters, you have to actually be on site. I would say that's a misconception. Um, Having a certain degree or a certain job experience to be able to make a difference, to be able to contribute, I would say is also a misconception. Um, there are so many things that can be done on the local level to make an impact, and There's not a necessary degree requirement or a job history, because the most important thing that I've noticed in disaster response is that um, the local communities, the one making decisions at the local level, requires local knowledge. And that's not something you can learn with a degree or a job. That's something that comes from experience, being there and living there. And so your experiences and your local community are going to drive decisions, not your educational or background experience. Um, and that one other misconception I'll mention quickly is that if you prepare for a tornado or a hurricane this year, you don't need to prepare again. You've got your plan. You're all set for a long time. That's also a misconception. Um, uh, Hazards change over time. Our climate changes over time, and the most up-to-date emergency management practices might change over time. And so it's important to reconsider. I would say at least annually, your community's and your own household's plan for whether there's a tornado coming or earthquake or hurricane, et cetera. What are you doing? What is your community doing? These are things that need to be revisited, and ideally, the more people that are informed about the up-to-date approaches to mitigating risks, the more resilient your community is going to be to disasters. And so I would say that having a hazard plan set for now and thinking that's going to take care of you forever, I would say is a misconception as well. In terms of some of the data that we use, I've mentioned Earth observation data, satellite data. NASA has a variety of satellite assets for remote sensing. However, we also, in our efforts, we collaborate with a lot of other governmental and commercial groups that also provide Earth observation data. Some examples of other partners include the European Space Agency, ESA, as well as some of the commercial private sector companies that provide satellite data as well. Remote sensing observations really give us the ability to help communities make informed decisions. Especially here at NASA, we're working on developing free and accessible resources that utilize Earth observations. And through those Earth observations, we can help to reveal how our hazards interact with things like social vulnerability, exposure, and the ability to cope in what is a changing climate. And so some of the tools that we work with for using satellite data for disaster risk, resilience, response, and recovery include computer science, so working with scripting with things like Python, as well as geographic information systems, GIS, some of the primary tools that we utilize to help develop derived products from those Earth observations to help provide decision makers with additional information to help make more informed decisions. And so the most important part of preparing for hazards for citizens, I would say, is to understand your exposures and your vulnerabilities, to really make an effort to think about, what you would do in certain situations, and make sure that your neighbors are informed too. I think sometimes working in the weather community, we might take it for granted that everybody else knows what to do when there's a tornado or hurricane coming, but that's certainly not the case and something that we shouldn't assume. The impact of a hazard is going to be more of a disaster when the exposure and vulnerability of populations are higher. So by reducing local exposure and vulnerability in your community, you are reducing the likelihood that a hazard is going to become a disaster. And so to kind of wrap up my contribution to this virtual panel, some advice I would give to someone that wants to do something similar to what I do here at UAH supporting the disasters program. I would seek out opportunities, even if they're in tangential fields. Find specific skills and roles that you like, and through these opportunities, you'll probably find things you don't like, and that's okay too. If you happen to be a college student watching this, oftentimes your professors are going to be in tune with some opportunities for motivated students. So I'd highly recommend talking with them. And for anyone in the community, ask your community leaders where there may be opportunities to volunteer when it comes to preparing for natural hazards. What are your community's plans? And even your local community, like your street or your neighborhood, your HOA, there would be opportunities to inform the community about risks and help your community become more resilient when hazards inevitably arrive. If you would like to contribute to solutions at the local level, you can make a difference in your local community. Get involved in your local community's resilience and preparedness efforts. A good place to start is online or through something like your town. Oftentimes, towns will have task forces or committees that are specific to disasters. And so I highly recommend reaching out to your communities and seeing where there might be opportunities to volunteer and contribute. Even local knowledge is highly valuable in this area. And finally, my last advice that I would give to someone who wants to do what I do is be willing to think outside the box. We need innovative solutions for today's problems and tomorrow's problems too. We will always have hazards, but we can make less hazards turn into disasters with the efforts and ideas of the full community across the disaster cycle, from risk through resilience, through response, through recovery. So again, my name is Ronan Lucy. You're welcome to reach out to me via email at ronan.m.lucy@nasa.gov. And thank you again for the opportunity to speak and participate in this virtual panel. Take care.
Hello, everyone. Welcome to Rocket City WeatherFest 2024. My name is Hannah Pankratz. I currently am a postdoctoral researcher in the NASA postdoctoral program, also known as NPP, at Marshall Space Flight Center in Huntsville, Alabama. At MSFC, I am located in the Earth Science branch, working with my postdoctoral advisor, Dr. Andrew Molfen, on utilizing remote sensing data for post-damage assessment after severe weather, primarily focused on severe thunderstorm damage. But before getting a little bit more into my current research, a bit about me. I did not originally start off in severe weather, but actually geohazards. Both my undergrad and PhD are in geosciences. So I worked primarily with remote sensing data in my PhD to study a very different type of natural hazard, which is land motion, land movement. And I would look at stacks of data over a specific period of time and be able to see if the ground was either uplifting or subsiding. And this could be either caused naturally or anthropogenic human-induced, caused by things like groundwater pumping or wastewater injection. And so through this methodology, though, you can study lots of hazards, volcanoes, earthquakes, landslides. And one area that wasn't really being studied using this particular data set was severe weather. The particular data set was that I primarily use is synthetic aperture radar, or SAR. SAR is an active sensor, so it can see through clouds, collect through most weather, and is independent of solar illumination, unlike optical imagery, which you're probably most familiar with seeing. So SAR has this huge advantage that maybe an optical image was collected, but it's cloudy, we cannot use it, and that image, though, is necessary because things are very critical right after a large severe weather event has occurred. So we want imagery as fast as possible with the lowest amount of latency from acquiring to delivering and processing that imagery. I would say now that I study tornadoes, can be very difficult. Any natural hazard is difficult to study because people's lives are forever impacted, and I just tell myself that I am doing my part in helping to mitigate these hazards, and one of those is being prepared. If you have a plan, then you will be focused on executing that plan, and then maybe panicking later. So being prepared is a huge part, and that has actually helped me a lot since moving down here and being surrounded by a lot more severe weather than I used to be. So a couple of places that, especially if you're interested in looking at damage from tornadoes, that I use to validate my data is storm data, as well as the damage assessment toolkit from NOAA and the National Weather Service. And this provides the damage indicators as well as images. It's a really great resource to have when validating my data, which is remote sensing data. And so it provides that ground truth validation. And again, I really encourage you to look frequently at the Storm Prediction Center, or SPC, in their outlook, especially if you have something planned. Weather does change, but I used to never use the SPC. I never used to use weather.gov or really any radar app. And that has all changed since I moved down here and become more weather aware. So just to kind of wrap up here, my journey to my current position and my current work has not been linear, but I can say that I have thoroughly enjoyed investigating severe weather, and really excited about the products that we can generate using the data set that I have used for very different applications, primarily in the geohazard realm. So thank you again for the opportunity to speak. My name's, again, Hannah Pankratz. Stay safe out there and enjoy the rest of Rocket City WeatherFest 2024. Bye.
Hello, everybody. This is Dr. Aldu, Assistant Professor from School of Civil and Environment Engineering and Construction Management at the University of Texas at San Antonio. So today I'm very happy to be here to be able to share some of my personal experience in risk assessment for natural hazard engineering, and also hope they can be inspirational to everybody. So my general research focus is on quantifying how civil structures and infrastructures behave and respond under natural hazard impacts, and also offer risk-based decision support to improve the resilience of the regional built environment. And more specifically, I do research in multi-hazard risk and resilience assessment, statistical machine learning and surrogate modeling, uncertainty quantification, and artificial intelligence assisted decision making, and also risk-informed lifecycle assessment of infrastructure systems. I actually have personally experienced the 2008 Wenchuan earthquake back in China when I was in high school. So although my hometown was more than 300 kilometers away from the epicenter, we were still able to feel very intense ground shaking. So it's really hard to imagine what people near the epicenter actually experienced on that day. So I think doing research in earthquake engineering is very meaningful, as it can help save lives and make the built environment more resilient to earthquake impacts. Okay, so and moving on, so in terms of how research can have a positive impact to the public infrastructures or structures, especially when facing different sources of uncertainties. So I think nowadays we have a variety of tools allowing us to quantify the uncertainties from different physical processes. Because we have to understand that in order for the natural disasters or earthquake to finally impact the physical structures, and then we eventually have some socioeconomic consequences, there are multiple different individual components or sources involved. Yes, which is why we need to quantify the physical processes as well as the uncertainties associated with them. Yeah, so that we can propagate those uncertainties into risk assessment to support risk-based decision making. So I think nowadays we have all sorts of analytical tools to allow us to do that. And also one important part, I think, during this process is we need a lot of data so that we can either use the data directly or develop some empirical models. So which I think that really takes a lot of joint or collective and interdisciplinary efforts from different researchers from different areas in the globe. So I think this is also what makes earthquake engineering interesting, because we can really learn from other people from different parts of the world. Okay, so and also I think with the recent advancements in physics-based modeling of infrastructure and structures, also mathematics and statistics, as well as machine learning or artificial intelligence, so we are more capable to provide more confident and reliable estimates of how these structures and infrastructure will respond under natural hazard impacts, and thereby offer more informed suggestions on risk or resilience-oriented planning, risk mitigation, and post-hazard emergency management. And also another aspect is especially in a post-hazard context. So we can leverage the newly recorded sensing data, let's say from seismic accelerometers, satellite images. So we can update our prior knowledge or probabilistic estimation using those newly obtained information, so which can further reduce the uncertainty in our estimates and then better understand what is really happening after those disasters. And so I think as for in terms of the new policies or how research is eventually implemented into practice, so I think it is a gradual process, because eventually in order for the research product to be effective, it has to undergo a lot of iterations of validation. Okay, but I think we are making great progress, because, for example, in terms of earthquake engineering, during the past several decades, so there have been many research endeavors to develop earthquake early warning systems, okay, or make civil structures more resilient to seismic damages. And also those research findings have been most of them have been transferred into building codes, so that we can actually build new structures more safe, or to make existing structures to be more resilient by retrofitting. Okay, but of course, there's always going to be a time lag between academic research and their actual implementation in engineering practices. And another aspect I think that's very important is to communicate with stakeholders or policymakers, so that we are, as researchers, we can make our voice heard, and also we can know about what is needed in the field, so that we can make our research meaningful to the society. And also communicating about uncertainties or talking about uncertainties is always challenging, especially when talking with stakeholders who mostly expect some sort of deterministic answers or yes or no answers. Yeah, but since we have uncertainties, so we can not really say that. So which is why it is very important to make our research findings to be more understandable or interpretable. Okay, so that they can be better received and or interpreted to convince people. So with that, I think that's all I have to share in this presentation or talk. And so with that, thanks for your attention, and hope they can be some sort of inspiration to anybody. And also wish you have a great time during the 2024 Rocket City WeatherFest. So thank you so much.
Hello everyone, my name is Arelis Rivera and I am a meteorologist and emergency response coordinator with the Atmospheric Technologies Group at the Savannah River National Laboratory. And first of all, I want to express my gratitude for inviting me to be part of this natural disasters panel. Meteorology and weather, as you know, is part of the origin source of some of the natural disasters we see day to day. So I am very excited to be a part of this panel. I have a couple of bullet points here in the screen in front of me of things I want to share with you today. So I really hope the things I'm sharing with you today will be helpful for your career as well as for understanding other areas where meteorologists and environmental sciences professionals work, and maybe give you an idea of things that you could do in the future. First of all, I'll tell you a little bit about me. I am originally from Puerto Rico, and there I grew up exposed to hurricanes, severe thunderstorms as well, even though not the same kind as in the US. And so that kind of hooked me in with weather. I wanted to be a meteorologist since fairly young. I just didn't know kind of like the path that I needed to follow to become one. Ultimately, when I was around high school, I finally understood I had to take a lot of math. So that scared me a little, but ultimately I did decided that this was the area I was really passionate about. So I started to pursue experiences and as well as academic preparation in the area. Now, being from Puerto Rico, at the time I was doing my undergrad studies, there wasn't an official program in meteorology. So what I did was I did my undergraduate program at the University of Puerto Rico Rio Piedras campus, and I did a Bachelor's of Science in Environmental Science. Now, while I was there, I already knew that I wanted to focus on meteorology, so I took advantage of several opportunities to kind of get my feet on the ground and start understanding weather-related things. Now, there wasn't a lot in weather forecasting, which is the part that I was always very interested in, but I say, why not take a stab at research? So I took advantage of an opportunity working with atmospheric chemistry research group in the UPR. There I learned a little bit about transport and pollutants in the atmosphere and how they move all the way to our tropics from the Saharan desert. Then I also took advantage of REU and other internship opportunities during my summers when I was an undergrad. And I'll tell you a little bit more about the benefit of doing that. But those opportunities, I was able to learn about some more atmospheric chemistry, as well as changes in microscale meteorology. I got to do a really cool project with an REU program that was looking at changes in rainfall during a small change in elevation in Costa Rica. So I got to travel, I got to do field sampling, and that's where I knew I really was interested in hydrology, rainfall, ecosystems type of thing, more of a holistic approach to meteorology. Still was interested in the forecast, but if I were to do research projects, which I needed for my graduate degree, I wanted them to be tailored to that topic. So with that, and with knowing that I really enjoyed my hydrology class in undergrad, I then decided to go find a program that kind of combined both meteorology and hydrology, and I found the University of Arizona's graduate program. And there I obtained my Master of Science in Hydrometeorology, which is a mouthful, yes, but essentially it combines courses in hydrology and coursework in atmospheric sciences. I got to do research as well for my graduate thesis, and I also was part of a program that allowed us to experience or kind of relate ourselves with other professionals in the field that had gotten a PhD. It was called the Bridge to Doctorates program. I joke that I was kind of like the black sheep of that program because at the end of my master's program, I had decided that I wanted to stick at the master's level. And the reasoning was the following. I still knew I was very much interested in operational meteorology, providing forecast, providing customer support, looking back at weather archive data, etc. For those types of positions, in many places, a PhD would overqualify you. So I wanted to make sure I could at least have some experience in that area of operational meteorology before I decided whether or not I wanted to continue the PhD. Spoiler alert, I haven't continued my PhD. I'm doing good. I'm enjoying the operational weather forecast. So that goes to show that not everyone has to necessarily follow the same path. If you want to do a PhD, absolutely good, because there's still a lot of unanswered questions in the area of meteorology and applied science. But if you want to stick at the master's level and work more as an operational support position, then you can absolutely do that in different areas, not only the National Weather Service. So one of the things that I would say in my relatively not so short career anymore, but in the years that have kind of molded and shaped my career, things that I am proud of is those internship opportunities I took advantage of. They really helped me define what I did and what I did not want it to do, which is just as important as figuring out what you want to do. I realized I didn't like atmospheric chemistry as much. However, a lot of the skills that I did pick up in those research experiences, I get to bring back in my position today. So even though I'm not fully doing atmospheric chemistry, having that background is helping me conduct some of my atmospheric dispersion and consequence assessment modeling today. Aside from that, when I got done with my master's, I went back to Puerto Rico and I got to work in a science exhibition, and that helped me a lot with my communication skills with people not in the field of atmospheric sciences. So I got to communicate with people who may have had a high school science background, who may have a PhD in some other field, or people who were somewhere in between. And I got to communicate complex scientific and atmospheric and hydrologic terminology and processes to people of such a wide background that now that I'm working in the area of emergency response, where I have to conduct some modeling and then brief on the results of that modeling to people that may not have the same background as I have, those skills have transferred to my daily duties here at SRNL. So, and last but not least, working at SRNL for about 7 years, it was a very steep learning curve on the first couple of years, but now I've gotten the opportunity to even mentor a student who did an internship with us last year. And I also accepted to be the chair of the Consequence Assessment Modeling Working Group within the DOE-wide Meteorological Subcommittee, which is a really cool position because I not only learn about what we're doing on site and get to share that with other people, I learn what other DOE sites are doing in the area of my expertise. So it's really, really cool. It's something I'm very, very proud of. And it's really good for developing our consequence assessment and emergency response skills DOE-wide. So one of the questions the planning committee shared with me, getting into more of the natural disasters or emergency, is how natural disasters have impacted my career. As I mentioned, I grew up in Puerto Rico. I was constantly hearing about hurricane preparedness, getting ready for like flooding events, wind events, etc. So the point of being prepared before the event and having a plan and a strategy in place has really been ingrained in me since I was a young kid. So that's kind of part of my DNA now, and I get to exhibit that part at my job now. I got to think of the worst and help plan or design scenarios that would make us practice and help us in that planning area. So it's kind of natural at this point for me because I've been thinking about it since I was young, given my exposure to hurricane. Now working in a DOE nuclear facility where I work at, we have to always think about the worst that could happen and how can we plan for that better to ensure our response, if that time comes, it's quick, it's effective, and we can protect the safety and well-being of not only the employees of SRS and SRNL, but also the general public if there's dangerous situations associated to a release. So that's really how being exposed to all these natural disasters and natural events and my curiosity to understand them has really helped me kind of have that mindset of, okay, what's the worst that can happen? How can we prepare to be ready for that and to react and protect ourselves, if that makes sense. The other big thing that I wanted to share with you all today was some of the good and the bad of emergency protocols. Now, I mostly work on the emergency preparedness and emergency management side of our group, which not only deals, of course, with natural disasters, although that's a really big part of our work, but it also works with hazardous material. So things that I've seen that are good strategies or emergency protocols that have been effective is really taking seriously those planning stages. And by that, I mean the drills, the exercises that we do. If we don't take them seriously as planners or as players in the exercise, or general public or general employees don't take them seriously when they're executing, then when the actual emergency comes, you may have missed areas where you needed more information, where you needed to improve. So taking seriously those planning stage is a very effective protocol. And with that, constant questioning of what can we do better than last time. Another thing that helps in planning is the communication and clear delegations of tasks and duties, which kind of brings me to the bad side. What things are ineffective or what protocols? When you don't have a very clearly defined communication pathway or a clearly defined delegation of duties, things can go awry really quickly. In the sense that you can have, for example, if people don't know their specific roles or duties, you can have people that are redundant, so two positions working on the same thing, and then lacking coverage on other areas. Or you can just have no coverage at all on some areas. So having that strictly defined beforehand is really, really important. And the communication needs to be clear. And another tidbit I'll share is that in consequence assessment, in emergency response, and even in your daily jobs, whatever you end up doing, there's not an expectancy that you in your position need to know everything. Not everyone knows everything. What is important is to know who to call that knows the answer. So if we have a chemical release, I may not understand very well the chemical qualities or how that chemical interacts with the asphalt, say. But I know who to call that can give me an answer, or at least guidance on that. That's what's important. I don't need to know the answer, but I do need to know that, I can collaborate with other people to help me get to an answer. And I have two more questions that I wanted to cover from the questions provided by the planning committee. And this is a fun one. What are some of the biggest misconceptions you've seen related to your field? Anyone who is in meteorology knows there's plenty, so many misconceptions with our fields. But I think the one that we struggle with the most is like the precision and accuracy of certain forecasts and the general public understanding the nuisance of numerical weather prediction models. And by this, I mean, now we have access to weather apps, which are awesome. I have nothing against them. The problem is when we, as a general public, we don't understand really what we're receiving, the information that we're getting, and the kind of like inconsistencies, or I guess the imprecision, if you may, of forecasts going out farther than a week out. Weather apps allow us to keep scrolling down, and we sometimes can see forecasts out to 2 weeks, I think it's the max, or 10 days or something like that. And during that time frame, there's really not much accuracy. There's a lot of error in numerical prediction models, but people have that information in the palm of their hands and sometimes may assume that's written scripture and that's gonna happen. We're gonna get rain in Huntsville 2 weeks from now on Wednesday at 2 p.m. We can't tell to that degree of exactness our forecast. To give you another example, I recently got a request for a forecast about a week and a half out to know whether there was going to be a severe thunderstorm and tornadoes on site. I mean, we have some idea where the larger scale systems are moving to with that much time in advance, but smaller scale interactions are not very well handled by models that far out. So understanding that, I think it's a very big misconception when I'm dealing with people outside the field that assume we just have a lot of certainty in our forecast beyond, say, 5-7 days. And that's really, forecast skill goes downhill the more days ahead it's going. Another big misconception is the difference between watches and warnings, which I will just be brief because I'm looking at the time and I don't want to be too lengthy, but just misunderstanding what those messages mean. It's very risky, very dangerous. I recently got a message from a local EMS message instating or instructing people to take shelter because there was a tornado watch. If you know, you know. Tornado watches are for a larger period of time, so that would cause a lot of issues because then you would have sheltered people for 6 hours or more when there was no tornado on the ground. So those types of misconceptions make our work very hard as forecasters sometimes. Makes it interesting and fun sometimes, but very hard at times. And the last thing I want to cover before I close out this video, trying not to be too extensive, is advice for people that may want to be in a similar field as I am or want to work as a forecaster in the public, federal, or private sector. And this is more of a general advice to anyone who is in their undergrad, grad transition or workforce transition time, is when you're in undergrad, there's so many opportunities like internship, job shadowing, undergraduate research, or undergraduate work that you can take. I strongly recommend you take them. If it's something that you think you might be interested on but are not super sure, take the opportunity because it's really gonna help you define, no, I don't want to do that, or I absolutely loved my experience job shadowing for Arelis at DOE ATG, so I want to do that. Or if you do a shadowing experience and you did not like it at all, now you know that's something you don't want to do. The other the other big thing is, and this is something I've learned recently, is that no career is linear. Almost no career is linear. I met so many accomplished people at DOE that started in a field completely different from where they are now, and the career kind of took ebbs and flows until they've made it to where they are. They are happy, they are accomplished. So just because you're starting out somewhere, don't be scared and don't think you're signing your life away to this particular position. Your career is going to take turns, it's going to go up and down, it's going to be what you make of it. So there's always opportunity to start somewhere and then change route, and that's absolutely fine. So with that, and almost reaching the 20-minute mark, I again want to thank everybody for this opportunity to be part of this panel. I hope some of the tidbits that I provided helped. But if you have any follow-up questions or are interested in opportunities for internship, shadowing, or just more follow-up information about what I do, feel free to reach out. I think my contact information will be available at the end of this video. So yeah, I'm happy to help, happy to provide any feedback or any tidbits of what I've learned in my career. Thank you so much and enjoy the rest of your day. Bye-bye.
Hello everyone, thanks for inviting me to participate in the Rocket City Weather Fest. My name is Hank Shima, and like many of you, I've always had a fascination for severe weather. Snowstorms, not so much, but mainly the supercells and the lightning storms. This fascination eventually drove me all over the United States, trying to capture these storms on film and video. And it's largely the beauty that I'm after. I think thunderstorms are one of the most beautiful things on this planet. Witnessing a tornado or a thunderstorm really isn't enough for me. I also want to document it in a way that I can relive the storm over and over again. I want to hear the wind and I want to hear the thunder in the video as if you're there when you're watching at home on your TV or computer. So having stable footage is of the utmost importance to me. And it turns out that there's scientific value in thunderstorms that are documented like this. I've been very fortunate to collaborate with meteorologists out in the field. And for 2 weeks a year, I joined Dr. Anton Simon's scientific field operations team, where we use high-resolution cameras to document tornadoes. And then later, Dr. Anton is able to triangulate particle motions or debris that's flying around the tornado, and he can make really important calculations on wind velocities that are occurring underneath the radar. Obviously, there's an ugly side to these storms. About once a year or so, I'll come across a devastated community, and storm chasers are usually the first ones on the scene, and many of us want to help out in any way we can. Sometimes it's just keeping somebody calm or letting them use your cell phone, and other times you might be driving somebody to the hospital with a minor injury. Sometimes their good intentions can exacerbate the situation. I can recall back in 2014 in Louisville, Mississippi, there was an EF4 that I was following, and I came across a row of half demolished houses, and several of us ran into the houses. You know, you're wondering, is somebody trapped in there? Is somebody unconscious in there? And we found a woman with severe head trauma, and somebody yelled, "We need to move our cars." And so many people had came in to help that it just started piling up. Cars were blocking the path for the ambulance to come in. And luckily the ambulance wasn't there, but you could hear it. Everybody jumped in their cars, moved their cars off the road. And luckily the ambulance was able to get the woman out in time, and we weren't holding the ambulance up at all. But, you know, what if we did? What if one person didn't hear that we were moving the cars and held that vehicle up for a critical minute? So you got to be really mindful when you're helping that you're not clogging up the roads. You want to keep the roads free. Another thing is you don't want to become a victim yourself. That's the last thing you want to do. And there are power lines down everywhere under these devastating storms. And you'll see people walking all around them, stepping over them, jumping around them. And they don't know that if these power lines power up again, it could kill them all. It could knock them. It's happened before. So keep your distance from the power lines. If you're one of the first responders to arrive at the scene, you might see people walking around with mud and blood all over them. They have this blank look on their face. They're in shock of everything that they've lost, of what has happened to them, and they look like zombies. And the last thing you want to do is go up to them and go, "Oh my God, you're bleeding. Oh my God, you're bleeding." And I always try to throw them off with a statement or a calm question that doesn't apply to them. I remember in Sosa, Mississippi, there was a guy walking down the road, and he had mud and blood all over him, and he had that look on his face. And I walked to him and I said, "Sir, do you know who lives in that house over here? Just, maybe they can help." Throw him off. And he said, "Yeah, that's my house. It took 20 minutes for me to crawl out of it." So he was fine. He was a tough guy. He didn't want any help. You'll get those guys too. "I don't need any help." I always try to sit them down. Just have a seat. Just have a seat. I always try to sit them down. I remember here in Texas, a couple hours from my home, I found a woman who had head trauma. She had a concussion. Her husband had a broken neck, and he was lying on a slab of cement that was his house, writhing in pain. I don't know how they survived this tornado. And we couldn't move him. I remember trying to find something to put under his head because he just looked like he was in so much pain. There's nothing I can do for that guy. I'm not a medic, but for the woman, I can drive her to the hospital. She just had a minor head injury. Well, there was blood down her head, but I was able to convince her to ride with me to the hospital. And so she got in my car. Again, I'm kind of in shock, and you will be too. You're going to be freaked out. Be mindful of that and try to hide it. And I'm thinking, is she going to pass out in my car? Is she going to vomit all over my camera gear? You know, like what's going to happen? And so I just started throwing her off and joking with her and acting like it was no big deal. And I was saying, like, you better not be getting blood on my cameras back there. And she was laughing. And so just be mindful to put yourself into acting mode and to really help keep these people calm. You're going to want that. You're going to want somebody to do that to you if you're a victim. So, yeah, we're often expecting severe weather days in advance. If there's a day where you think there's going to be severe weather, the best thing you can do is just pay attention and keep your head to the sky. Keep your eyes to the sky. There's radar apps that you can get that I highly recommend. I use RadarScope. I think it's $10 a year. You can get free ones, you can get cheaper ones, but it shows you where the storm's coming, where the business end are. So if you don't have a radar app, I highly recommend one of those. If you don't know how to use it, there's videos that teach you how to use it. It's as simple as using a complicated toaster. I even have a video of how to spot a tornado on radar on YouTube. But learn how to do that, and if you spend the 5 minutes doing that, you'll know where the storm is, where the dangerous part is, where it's passed. And then the only problem to this is all your friends are going to start calling you and asking you, hey, where is it? Where is it? And so you got to call them all and tell them where it is. And then you'll see that, hey, I'm fine, but it's going to hit Tracy up here. So you got to call Tracy and say, just so you know, there's some rotation going over your house. I'm sure it's fine, but maybe get into an interior room. And so that's the next thing that we'll talk about. Is this is pretty obvious. You've heard it a million times, but just what room are you going to get into if there's a tornado warning? You know, you want to put as many walls between you and the outside world as possible. As many walls. You don't want windows. So if you've got a closet, everybody says, go to the bathroom. Well, our bathroom is right next to a big window right here, but it's not the kind of window you can see through for reasons that you understand. But our closet is in the center of the house. So that's the room that we get. And it's a tiny closet. So those are going to be stronger walls. So have a plan if the tornado's coming, and if you live in a mobile home, you want to get out. So you need more time. If you live in a mobile home, you want to pay extra attention to the warnings. You want to have your weather app and know where you're going to go. You know, do you have a friend that lives, a mile away, a block away? You're going to need a little bit more time if you have a mobile home. So do that. And what's going to happen? You're going to go to somebody's house. You're going to knock on the door. They're going to let you in. And then nothing's going to happen, right? That's how the warning system is. So don't lose faith in the warning system. There's a reason why they warn the storms. And don't get complacent the next time around. It'll give you an excuse to get out of your house, go hang out with some other people, have a real conversation that isn't on a device or something. So I hope you guys are having a good time at the Weather Fest, and the storm season's coming soon. And I hope you all have a good season, that you see some really cool, neato storms, but are spared any of the destruction, the ugly side. Take care.